welcome once again. This is Miss D, and we're talking about blueprints, and specifically, we're going to be talking about welding symbols. Welding symbols are like a code. You need to understand how the code works to break the code. And after a while, it becomes really easy, but you need to understand, okay? So there's a lot of information that can be used in a weld symbol without the need to write it all out. So some of the info that we use is for size, length, pitch, angles, root openings, and joint design, to name a few. So this can get a little tricky. Please don't freak out on me. Come on, guy. Here we go. So welding symbols. Oh my goodness, this is so confusing. Please don't. Okay. So here's what a welding symbol can encompass. It seems like a lot of information, but we'll break it down to better understand the welding symbol. So let's break it down. So for every type of weld and edge preparation, there's also a welding symbol that goes along with it. Symbols look like the joint looking at it from the side. If we go back to the different joint design and preparation, we can see it. So let's think about this. Remember we talked about a V-groove, a single bevel, a U-joint, a J, okay? Pretty cool, right? So we can actually look and see. And if we're not certain, we can always draw a line here and a line here, and that'll tell us what the joint looks like. Okay, so we need to know where to put the weld, okay? The welding symbol does this very simply, but it can be confusing at first. So let's break it down. The first thing you need to understand is the reference line. This is the reference line. Okay, this line is always horizontal, left and right like the horizon. This holds all of the weld information needed. Now, there are two sides to the arrow, okay? The arrow side, which is the bottom, and the other side, which is the top. If information is placed on the bottom or the arrow side, wherever the arrow points, this is where you're going to be welding. That's where the weld is made, okay? If the information is on the top, this is where it gets tricky. The weld will be placed on the opposite side of where the arrow is pointing. If the information on both sides of where the arrow points will be welded. So regardless of which way the arrow points, we can have arrows doing different things. The arrow side and the other side always stay the same, which means this doesn't move, okay? The information does not change places. It doesn't move around. It still stays the same. So this is the tail, okay? It's the end of the symbol. The tail is used in the symbol when other information may be needed to reference things. A tail can say a particular process, an electrode, a code or standard, a particular WPS, or a reference number, or the letters TYP, meaning that this is a typical weld, and where you see TYP, the weld will be the same. In some cases, there's one symbol that is detailed out with TYP in the tail, and then the other welds pointing to where they need to go will just say TYP in the tail rather than have all of the specific details. So let's look at the symbol for fillet and how where the welding symbol is placed where you weld. So the symbol for fillet is a triangle, okay? The up and down left, or I should say up and down line, will always be on the left-hand side. I always explain that you put up the up and down line anywhere else, you're not a very nice person, okay? So always put the line up and down on the left. So in the example A, we see that the fillet weld is on the arrow side, meaning where the arrow is pointing, the weld is placed. So we can see it here. Okay. In example B, it's placed on the other side, but the arrow is pointing in the same place, meaning you need to place the weld on the opposite side or the other side that the arrow is pointing. So we can see the example here. In example C, we can see that there's a symbol on both sides, which means I need a weld here and here, just like the example. Now, here's a tricky one. In the last example, we can see that there are two different symbols that make up the joint. So it says this side, and then this side and this side, which makes up that. Okay. Ooh. So as we talked earlier, we talked about the tail, right? So the tail is not a necessary part of the weld symbol, but you can leave it off if there's no information to put there. So as we can see, we don't need it. But if there's something important that we need or information that we should know, it's probably going to be in the tail. Okay, so we talked about earlier the arrow side of the joint where the point of the arrow is pointing, right? When we see a broken arrow and then it pointing, it refers to which member may be need to bevel or have some sort of edge preparation before the member gets welded. It's pretty much the same. So when we see this, there are examples of fillet weld, and the size of fillet weld must be made. The size of a fillet weld is the size of the shortest leg. So in order to properly size a weld, it must be the same height and width. So if the size is stated to be 1/4 inch, the weld must be 1/4 inch tall and 1/4 inch wide or sticking out from the base metal. So when we look at the symbol, the size is on the left-hand side before the symbol. So we can see right here, this is a 1/4 inch fillet weld. Okay. Size can be used in many different types of symbols and welds, so we can see it like this. This is unequal legs, means that they have to give a detailed drawing to say this is how high it is and this is how wide it is. Unless it is specified, we always want to make an equal fillet weld. So equal meaning 1/4 inch tall and 1/4 inch high. Okie dokie. So we can talk about different things that can be dimensioned. We're being very specific right now about fillet welds, and we can use a symbol to show that a weld is a certain length. The length is the first number after the symbol. Okay. If there's no dimension there, then it's recognized as a weld the entire length of the material, or it is considered continuous. Now, if there's something there, there also needs to be an additional number in order to use length. There's also pitch. And pitch is the center-to-center spacing between the welds. Okay, so let's break down the example. The first thing I'm going to look at is the symbol. Okay, here's my symbol. The triangle tells me this is a fillet weld. Okay, we want to always break it down simply. The number in front of the symbol is the size of my weld. In this case, it is 3/8 of an inch. So my weld must be no bigger than 3/8 inch tall and 3/8 inch wide. And the next number right here is 6. So this is the length. How long should my weld be? It is 6 inches. Now, here's my dash. Okay. And since our plate is longer than 6 inches, we also need to know the spacing, right? After the 6 is a dash, and then my center to center spacing, and it's 10 inches. Now, so here's the example that pitch is 10 inches. This means from the center of the first weld to the center of the second weld, from the center of the first weld to the center of the second weld is 10 inches. So how do you figure out what the spacing in between is? Well, you take the pitch and you minus the length. This would give us 4 inches. So that we know at the end of one weld and the beginning of another, there's a 4-inch space. And we also want to double check and make sure that's correct and that we measure out from center to center when we're laying this out. Whew. That's a lot of information, guys. I'm glad you're hanging in there. Okay, so intermittent fillet welds. They have a lot of uses. One of those uses is to assist in protecting the material from warping or distortion. You can also use intermittent welds for thinner materials so you don't burn through, or even protect a weld so that it doesn't crack. Plug welds. Plug and slot welds use the same welding symbol, and the symbol is a little square. They use the same symbol because from the side view they look the same. So we can see here, this is a plug weld. This is a slot weld. Okay. So first we need to know, what is a plug weld? A plug weld is a hole or holes that are cut into the top material. Then the top material is placed on a base material and it's welded. Now, a slot, it's almost the same, but a slot is an elongated hole with a couple of different attributes. The slot can also have length and width. So the first number that is before the symbol, right here, this is size. Okay, in the case of the first number, this is also width of the slot. We always measure the size of our plug and our slot from the base. So at the base, it will be 7/8 of an inch from the bottom. We don't want to assume it at the top because we can also have an angle. We'll get there, okay? But let's keep it simple, okay? So we know that the first number is diameter if it's a plug, or width if it's a slot. Okay, so remember, a circle can't have length. So if you see length, this is not a plug weld, okay? So we can see here, there's a length and a pitch, right? Or length and a pitch. Here, we just have a pitch. Okay, so the other number after the length is the pitch, or the center to center distance. So if there's one number, we know that it's a plug because there can't be length. And if there are two numbers, then we know there is a length and a pitch, and this tells us this is a slot. Okay. There's also depth of fill, meaning how much do I need to fill this plug or slot weld? Okay. And I know this is a lot, guys. Take it easy. We're getting there. So in most instances, this box will be empty. Okay. But this means that the plug should be filled to the top. If there's nothing in here, it is assumed that it is all the way to the top. If there is a number in here, this tells us in inches how full this should be. So in the example on the right, it shows 5/8. This is a dimension and not anything else. So this would be 5/8 of an inch. So if I had 1/2 in the box, you would fill it up 1/2 inch, not halfway up. So the last piece of information tells us how many. Okay, this tells us right here in the parentheses how many should be made. So this tells us this is a 7/8 inch diameter plug weld. We need to have it spaced at 3 inches, and I should have 3. Now here's this one. I have a 1 for width. Okay, that's my width. Okay, and I have a 3 for length. That's 3-inch length. Okay, and it says I have a center to center at 5. Okay, that's my pitch, and I need 2, and they need to be filled up at 5/8 of an inch. And usually, if you have something like that, it will be detailed usually. Okay, onwards. Now, see what happens when we see plug or slot info on the other side. This is how it looks, okay? So they will also use this information here. This is a symbol for diameter. So what type of weld is this? So what is going to give me the information that this is a plug or a slot? So I see the symbol for diameter, right? Well, diameter is for measuring a circle. So we know that this is a plug weld. What is the size? 1 inch. What is the depth of fill? 1/2 inch or half full? This is 1/2 inch. The number to the right of the symbol is for what? So since this is a plug weld, then this is for the pitch or center to center spacing. So what is the pitch of the weld? 5 inches. And after that, how many are there? 3. Whew, that was a lot of information, guys. You're doing great. Okay, so spot welds are like plug welds, and this can get confusing. Spot welds are circular, but there is no hole or a slot to fill. A spot weld is usually used with thinner materials. A spot weld can be made on one side and penetrate through the top plate to connect the base plate to it, or it can be on both sides when we use resistance spot welders. So spot welders like these are usually a resistance type. So the material is put between the 2 little copper points here or here, okay? So this is a hand one and this is a foot one. And the material is squeezed, and then heat is introduced through these copper tongue things and introduced right at that point, so it melts both metals at the same time, and it creates what's called a nugget. Okay? The copper conducts electricity, but many materials don't stick to it, so it's often used for resistance welds. Okay? So, spot welds. We can see here that the symbol sits on the reference line. And it is a circle. We can tell what size or strength it is. So size or strength can be on the left-hand side. And then the right side can also tell us pitch. The tail also will tell us maybe a particular type of welding process. Okay. We can see here that the symbol sits on the reference line. This is when it goes on both sides. And the quantity of welds is in parentheses. This number here is in newtons, or how strong does it have to be? 200 newtons, 800 newtons on both sides, 600 newtons on the other side. I need a resistance weld on both sides, and I need to have 5. Okay? Getting a little simpler now. Well, maybe not. Okay, so seam welds. Seam welds are kind of like spot welds because usually we use some type of resistance welding, but they're not circular. It's kind of how plug and slot welds work. The symbol is a circle and it has 2 lines in it. So we can see the 2 lines. Okay. A seam, of course, is usually a resistance type weld, and the same dimensions are used like the spot weld. The number to the left, it tells us size or strength of the weld, so we can see that here. And the numbers on the right are length. And of course, we can have pitch too. Okay, so here it is. In the example here, the tail also tells us what type of process should be used. The symbol points to the place that it is to be put and how strong it should be. So let's break it down. First thing is, I'm going to look at my symbol. My symbol is a seam weld on the arrow side. It must be 200 newtons, and I must do it in electron beam welding, and it should be placed right here. Pretty simple. It's getting there, right? Now you're starting to decode it. All right, well, let's go for some groove welds. So different types of groove welds improve the strength of the overall weld. There are also dimensions that are particular to a groove that are necessary in order to make the correct weld. So we need to understand the symbol for each type of the groove. In the example, from the top to the bottom, V groove, right here, okay? We notice that the weld is placed where the arrow is pointing. It points here, which means this is the side that we want to work on and bevel, and the groove is going to be right here. Double V groove. Double means both sides. So it points here, which means one is going to be here and the other is going to be on the opposite side or the other side. It's making sense now. I can see it. Everybody's going, oh yeah! Right? I'm sure. Okay, so let's see here. Now we can see the third one. This shows a V groove, but there's a size in front of us. So what does it tell me? This tells us that the groove is only 3/4 of an inch of the thickness of material. So it kind of shows us here. So it says, this is the thickness of my metal, and this is how thick I want my weld, or the size of the weld, or depth of preparation. The fourth one, it gives us a lot of information that may not be seen at all times, but it's important to understand. The 1/4 inch right here refers to the size of the weld, or how deep the groove is prepared. The 3/8 in parentheses, this tells us how much penetration the weld should have. So it has to be a 1/4 inch that has been ground out or beveled, and we need to make sure that it's penetrated up to 3/8 of an inch. Okay, now the fourth picture, it shows us a new symbol. Okay, this symbol is for what? Do you know what it is? This is the symbol for square groove. The number inside the symbol is the root opening. Root opening is what? How far apart it needs to be. Right? So it says 1/16 of an inch. So these must be put 1/16 of an inch in order to get proper penetration. We also have another groove here, right? The V groove. This one tells us the included angle, or the total angle for the joint, is 50 degrees. It tells us right here. This is our groove angle. Okay, so what would my bevel angle be? So you would divide 50 by 2, and your bevel angle should be 25 degrees. So this member is 25 degrees bevel, and this member is 25 degrees, and 25 plus 25 equals 50. Okay, so the root face. This allows for better penetration. If the root face is too large, you can't get down to the root and have successful penetration. We need to make sure that it's not too far, too close, and then this edge here isn't too big. And usually it's about a 1/16 to a 32nd. It's not very big at all. Okay, so here's another type of groove weld. This is a flare bevel groove. Think of this like a plate to a round piece, or a piece that has a rounded edge, like the example. Okay, so a plate to a round. Our symbol is going to look like that, a plate to a round, and this is on both sides. So that means I need a weld on both sides. Pretty easy, right? So when making the single flare bevel groove, the up and down line will always be on the left side of the symbol, and the other side is like part of a circle, kind of like a fancy circle here. Okay, so the flare V, circle to circle, right? A round to a round piece of material. So when we look at the joint, or I should say the symbol, it's going to be a round to a round. We can see the flare V groove, it has 1, that is the size, and the 5/8 is the depth of weld. I don't know if you guys can see it. 1 is my size, and 5/8 is my depth of weld. The same thing applies to the double flare bevel on the right. So it says My weld should be 3/4 inch, and I need to have 3/8 inch penetration. Flanged welds. Usually flanged welds are on thinner materials, and as we can see, the flange is just opposite of the flare. Flanges are going to be on the edge of the weld. The numbers on the left indicate the radius and height separating, and they're used with a plus sign. The size of the weld, meaning how high the weld is, will be to the right. So this isn't too common, so don't stress about it. So ultimately it is 1/8, 1/4, okay, and then how tall. Okay. Backing. A backing strip, backing plate, they all refer to a backing. So many times a backing is used to ensure complete joint penetration. In some cases, the backing is shown on the symbol. The R tells us the backing must be removed after it has been welded. There are also some backing strips that are made of other materials like ceramic or glass reinforced tape. We can also have what's called a consumable insert, which is used as a backing strip and it becomes a part of the weld. If a particular type of backing must be used, it will be noted in the tail usually, and it'll tell you ceramic backer or consumable insert. All right, guys, this is the end of this part. We got one more. As always, take care.
Thank you for watching. There will be several parts to the lecture. So, weld the world.